Alright, so this problem we're looking at a molality problem. So we want to know what the molality of a solution that contains 63.0 grams of nitric acid, HNO3, in 0.5 kilograms of water. So we're looking for molality, which is lowercase m, italicized. I'm italicizing it the best I can. And that's going to be moles of solute over kilograms of solvent. I'm having trouble writing and talking at the same time. Brain's going too fast or too slow. I like to think fast. Anyway, of solvent. So what else do we have? Well, we've got a mass of our solute. That's going to give us 63.0 grams. We also have a mass of our solvent. So let's do solute, solvent. That's going to give us 0.500 kilograms. Whoever wrote this problem was very nice, because one of the things that we need is already in the right units, and that's going to be our mass of solvent. It's got to be in kilograms. So what we have is 63 grams of nitric acid, HNO3, that we're going to have to turn into moles first. So let's do the mass to mole conversion. So 63.0 grams of HNO3. Get your crossbar set up. And I gotta find the molar mass of this. So without looking at the periodic table, I mean, it's just we'll take it to one decimal place. So oxygen's about 16. So 16 times 3 goes 48. Plus nitrogen's right around 14. So 48, 58, 62. Plus 1 for our hydrogen is going to give us 64 grams per mole in 1 mole. So just to see how many moles this is, looks like it's going to be very close to 1. A little bit less. So let's see. Clear 63 divided by 64. That'll give us about 0.98 moles, or 0.98. We'll do 2 sig figs because this is what we have for our molar mass. But if you looked at a periodic table and took it to further places, we'd be limited to 3 sig figs with the problem, what it gives us. Alright, so this is going to give us 0.98 moles, and molality, we said, is moles of solute over kilograms of solvent. So 0.98 moles over 0.50 kilograms. That's going to give us, well, basically we're going to double this, so that's going to give us 1.96 moles per kilogram, or little m, or molal, however you want to say it. So again, like in the last video, I like using units instead of like a big M for molarity. I would like to use moles over liters. It helps me see relationships a little bit better. But this is how you do a molality problem. We'll do one where we do colligative properties, where freezing point depression and boiling point elevation will be a part of that. We got to figure out our molality, so we'll integrate this into a little bit more difficulty in a future problem. So that's it for this.